This shows a simulation of approximately the SL12 cable hanging from this vessel, which is roughly the right size, used on another project a few years ago. And this is a plan view looking down at a section on the seabed. The white indicates nodes which are on bottom, and the yellow indicates sections which are lifted off bottom. So here in this elevation, this section is all lifted off bottom, and these white nodes are on bottom. I'll set the thing playing, and we'll see this is playing real time, so the nodes on bottom are lifting up and setting back down, and we see this pattern of compression waves occurring on the bottom when the system is set back down. This is a closer view of the system in side view, which I could make full screen, and we see the system all on seabed in this short section here. This is only 3 meters scale, and shortly we'll see it pick up from this end as the vessel above is heaving upwards, and then it'll be set back down. The individual node spacing can be seen by the white dots on the seabed, and here you see a compression pushing the section of cable up, and that happens quite often. We'll probably see it again quite clearly here. Well, I said, but we didn't. Anyway, it's a random simulation in a sea state 6, so we'll go back to the full screen, and here is a range graph of the whole simulation showing umbilical curvature. So 1 over curvature is bend radius, so 1 over 0.5 is 2, so that would be a bend radius of 2 meters. 1 over 1 is 1, and there's the limiting bend radius of 0.8, and we see that in the touchdown zone we, during the simulation, have occurrences where we violate the minimum bend radius. Now these other graphs, here is for the whole simulation the actual tensions, and here's the allowable tension of 24 kilonewtons. So we never exceeded at this water depth, which is about 2,000 meters I think, the allowable tension. I guess at deeper water depths we did. And here's a time history of the top end A of the umbilical, and we see it's going up and down from about 12 to nearly 17 meters at times. And the bottom end tension, I apologize, I'm not reading these very carefully. That's the Y motion at the top end, 12 to 16. And here's the Z motion at the top end, from 4 to about 16. So a range of about 12 meters maximum in this 1,000 seconds of simulation. And now the tension at the touchdown here, we see it's got slight negative pieces. We could zoom in on that. And the curvature at the touchdown, we see it here regularly exceeding 1. Remembering that about 1.1 is the limit, so we're close to the limit. And here the Y position at the touchdown, we see it's been creeping, but it looks like it's reached a steady state after about 1,000 seconds. So a lot of things going on, a lot of things to look at in this type of simulation.